Hi folks, we're going to take a look at 2b here, and we're going to see that this one's a little different because we don't necessarily know what 1 over x squared minus 9 is going to look like. But the way we're going to figure that out is by considering this as being the reciprocal of the function x squared minus 9, which we know very well. Okay, so let me start here by getting some axes. Okay, and again, think about where you should put in your axis. So this here, x squared minus 9, is x squared brought down. So I might actually take my x-axis and bring it up a bit. Okay, there we go, x-axis. Now I know that this is going to have zeros, 3, and negative 3. So I think it makes sense to just go up by 1 on the x-axis. Okay, but on the y-axis, because I have to get to negative 9, I think I'm going to go up and down by 2. So 2, 4, 6, 8, and 9. There's my vertex for this function. Okay, I know it has x-intercepts 3 and negative 3. And I guess if I wanted to make this a little nicer, I might use the step pattern, maybe for a couple of other points. Okay, so don't have to do this, but if you do remember that, remember what the step pattern is for something like x squared minus 9. As x goes up by 1, y goes up by 1. Okay, and then here as x goes down by 1, y still goes up by 1. Sorry about that. Okay, and then from here we can draw a fairly nice parabola. Even if you just worked with the vertex and the x-intercepts, that would be fine. Okay, so there's our starting function. So our goal now is to determine what the function 1 over x squared minus 9 looks like. Okay, but I'm just going to follow the exact same procedures I did before. I'm going to start with the x-intercepts. Let's start with negative 3. I know that's going to make the reciprocal undefined, so I just look to see what the behavior of the function is going to be near negative 3. So from the left, I see that the values are positive and approaching 0. So if I take the reciprocal of numbers that are positive and approaching 0, they're still going to remain positive because taking the reciprocal doesn't change the sign, but these numbers, these y values, are now going to become larger. Okay, they're going to approach positive infinity. Whereas from the right, they're approaching 0, but from the negative side, so when I take the reciprocal of a number very close to 0, I'm going to get a very small negative number. Okay, so here we have an asymptote at x equals negative 3. And I hope you can see that I'm going to have a very similar behavior on the other side when x equals positive 3. So at a certain point, you just start to know what it's going to be. Here, it approaches 0 from the, so remember, I'm always talking about the y values. Y values approach 0 from the positive side, so the reciprocals are going to go to positive infinity. Here, I'm approaching 0 from the negative side, so the reciprocals are going to approach negative infinity. Okay? Let's look at the end behavior. Okay, I notice here that as x gets large, y gets large. So when I take the reciprocal of very large numbers, what do I get? Very small numbers, but still positive. So there you go. This is going to approach 0 from the positive side. Here I also have, as x goes to negative infinity, y values that are getting very, very large. So when I take the reciprocal, I'm going to get numbers that are very small, approaching 0 without ever touching. So we see here that we're still going to have a horizontal asymptote. Okay? The other thing we said we'd look at is let's determine where the original function is equal to 1 or negative 1, because then the reciprocal is just going to be equal to the same thing. So I notice here, there the function is equal to 1, there the function is equal to 1, here it's equal to negative 1, and here it's equal to negative 1. So we can start to see, like especially here, looks like I can draw this portion of the graph. Okay, here again, I can draw this portion of the graph. All right. This is where things do get a little dicey because these numbers are always negative. So when I take the reciprocals are always going to be negative. Okay? So how does this minimum value perhaps help us out to figure out what's going to be going on with the reciprocal function? So here what's happening? As I get towards that minimum, the numbers are getting more and more negative, okay? Until they reach their most negative point. They reach their smallest point. Well, when I'm taking the reciprocals of these numbers, okay, they're going to go from numbers like -2, -3, -4 to -1/3, 1/4. I'm going to see that they're getting closer and closer to 0. This is the value whose reciprocal is going to give me the number closest to 0. So what we have here, if you take, I guess here if you put in x equals 0, you get 1 over -9. That's going to be the absolute largest number. And I'm not going to be too picky about where we put it, but this is going to be the one that's largest out of all the reciprocals that are generated from these y values. So I can now draw the middle portion of this graph. Okay, so this is what the reciprocal of x squared minus 9 should look like. But just again, take a look at what we did. We still used the x-intercepts of the original function to determine the behavior near those x-intercepts. We still use the end behavior of the function to determine the end behavior of the reciprocal. Okay, we still found the points at which the function and its reciprocal would be the same when they're 1 and -1. And the last thing we used here is we saw that we could even use the maxima and minima to help us determine the shape of the graph, which is not surprising because extrema are one of the basic characteristics of a graph. Okay, so what I'd like you to think about as you're doing some of these other ones is, are there any patterns here? Are there things that you're noticing about these functions? Okay, so we'll stop here and we'll take up the last two.